Ladies and gentlemen, welcome back. Last time we looked at the train limit system or feature that has been added with Factorio 1.1. We also considered a couple of the ramifications of that, and we took some time to look at what I already have and how I might need to modify it, such as a central or centralized train yard, whether or not I need local stackers and stuff like that. This time we're going to look at my setups that I previously prepared for the old system, and we're going to see what I can adopt from it, how it might need to change. Let's go ahead and isolate one. Let's see, what do we have? Yeah, might as well stay up here. Okay, so what do we have here? First of all, these should no longer be necessary. This should not be necessary either. In fact, this entire part down here should no longer be necessary. This should no longer be necessary. Let's put a power brick in the system. And for the moment, we don't actually need any of these. Gonna settings, Control D. See, Control. Here. Just a quick look through everything. Yeah, okay. Hadn't done that before after updating all the mods, so it seems that some of them reverted to old settings. And I am pretty sure okay. Now let's see, what do we have here? This is a filter, I believe, from, should be, just simply from what's in the train. from what's in the green wire, which includes the see the green wire reads stuff out, puts it onto the red wire here in a filtered way. The red wire simply goes across here. It's done here. This handles the inventory of the train as well as the chests. The green wire itself. So these empty constant combinators are simply pins for the wires. So the wires aren't like all over the place. I've basically prepared some, you could call them cable channels or something like that. Okay. So this simply filters all virtual signals out from the green wire and puts the clean signal on the red wire, which is going over here and is going down into these combinators. And these two combinators are responsible for reading what my inventory is, as well as what the train has, adding that all together, giving me the output twice as just the raw output, as well as the total number. And what happens then, because remember that the entire train system here, each station is designed to serve one resource and one resource only. There's no mixed resources. That is not something that my system is capable of. You can actually do that in vanilla, but it gets extremely complicated. The systems themselves tend to be extremely UPS intensive. It's kind of slow compared to my system, but you do have the freedom of trains being available for anything, not just one resource that you designed them for, right? That's the difference between my system and something like LTN. So if you are interested in checking out what I'm talking about, LTN, there's a design called LTN in vanilla, LTN from the LTN mod, which basically simply provides you with a system that allows you to create like a huge train yard of empty trains that have no specialization, so they're not used for any one resource. Instead, the mod decides how many trains and how large the trains need to be to send them out to based on request, right? So stations request trains to be loaded or trains with certain resources to be unloaded in there, and LTN allows you to just use any train for that, and it handles the whole which train goes where for you. You can also manage to do that in LTN actually, in vanilla actually, but it is very complicated. The system is very complex. It's not easy to get into if you're not well versed in combinators. Bit of a chore. I decided to go with something simpler that's more fluid, but much easier to get into. Not as susceptible to user errors, and in my opinion a little bit faster, but it limits you in the sense that each station can only ever serve one kind of resource, unless item, whatever the item that is, right? Could be fuel, could be whatever. But in turn, you cannot but in turn you have to have dedicated trains. All right, back to the topic. So this basically cleans out the signal. They put these together, and this is basically an alarm system. It checks for whether or not there are more than the type. So what happens here, it adds together all the items that are in the train and the chests, adds them together, and then compares to the total number of items. And if the answer is equal, it's fine. But if you had, for example, 100 iron plates and 10 nuclear fuel, that would be 110 items in total, right? The E would be 110 total. But 110 total does neither equal 10 plates, 10 fuel, nor 100 plates. Therefore, the alarm would go off because it would consider the station to be contaminated, which is of course true because I don't want two resources at the same time. So if we test that, I actually have any. And yeah, you can see, right? As soon as I remove one of these, not sure what's going on here, I'll check that later. This is your alarm lamp. As soon as I remove one of these, it's no longer contaminated because there's only one item in here, and you can see E is 100, that's because there are exactly 100 in here. And this is also 100, which is equal. But as soon as I add anything, yeah, 130 total. But 100, neither 100 nor 30 fit. Therefore, the alarm is sounded. Right. There you go. And this over here is then inserter control. So these guys load trains evenly and also unload trains evenly. They take care that the load across all chests is always balanced. That's the job of these guys. Let's see what do we have here. These work on signal. That's upper and lower limits. I don't need these anymore. So these were thresholds whether or not the station should turn itself off. I do not need that anymore because now I have the function of how many trains. So the reason I needed this was because in vanilla I couldn't limit how many trains go to an on station. Every train that could go to the station would go to the station. The only thing that would split them up was the now defunct descent divisor tail. It would basically say I only need so and so many trains. My inventory is so and so full, therefore I'm going to turn half my signals red, for example, right? And half the signals red would induce a huge path penalty, and trains that might better serve another station would go there instead because it wouldn't have as many signals red. The problem was, of course, that if a station freshly turned on, there would be a huge influx of trains all running to the station at the same time. And to make sure that if that happened, it would at least be worth it, I had a system, a latch, which would turn the station off when it's not worth it for trains to come here in a bunch. It would simply turn itself back on when it could serve 10 trains or whatever I said in here. The upper threshold is when the station turns itself on again. So if it could serve 10 trains, that's when the station would turn itself on. All the trains would come here, would unload. Eventually I'd cross down to 2 trains. If the station can only serve 2 trains, then it would say consider itself not worth having trains come here. It would turn itself off until I'm back up at 10 trains again. And that's basically what this guy did over here. So black, not 0. Where does the black come from? So the check mark is for whether or not the station should be on. White is usually a reset signal. Where did I get black from? Shouldn't be any of these. They should not be connecting to anything in particular. Let me prepare something real quick. This is something I had forgotten to do. Global provider items. Stick up here. There you go. The memory should now be loaded. Indeed it is. The input. Black. Oh, right. That was a setting, whether or not the station. Right, so black was a control signal whether or not the entire system, whether or not the station should even be allowed to be on. So if I turn this off, there you can see the station is turned off, the lamp is red. This is my signal that the station, that the system itself is turned off, the computation of it. If I increase this to, yeah, come on, 1, there you go, everything's returned to normal. Right, so this was basically a check that this system up here always runs, right? But it is only allowed to actually pass the signal on towards the train station if the computation of it is turned on over here, right? So this is basically the final line before the station on signal is passed on to the station. This will determine whether or not the setting actually allows it in the first place, or whether I've just manually turned the whole thing off. Right, so I don't need these anymore. This is just a reset for the latch. This is I might guess, yeah, okay, so this is another control signal over here. This is whether or not I want the specific latch system on or off here. This might be important. So the black signal simply turns the entire station on or off, whereas the latch itself decides, it doesn't turn the station itself on or off, but it decides whether or not the thresholds are respected in the decision, right? So if I turn this to 0, basically the station is always forced to be on unless I have it manually turned off, so I can still do that here, right? But basically the station doesn't check anymore how many trains it needs. It can serve, and the thresholds I said are ignored. So that's useful if I want to make sure that I always have at least one station between loading and an unloading station. I want to make sure that at least one station is always available for trains to go to. So they don't stop like somewhere in the middle of the network blocking traffic because they have no destination to go to anymore, right? So what I basically do is I say, okay, unloading stations use the latch system, loading stations do not. I still do want that, I think. Actually, I don't need that anymore. What are these for? I do seem to remember that they are responsible for some of the computation down here for the signal, so I might not actually need them anymore. I might be able to just remove them. Let's see. If 4 divided by 1b, 4 is provided here. Gray divided by that should be memory is loaded. What is 1 again? So first of all, this is a loading station, so it needs to keep track of the items it has available. Four divided by 1. This has no output. This has no output. I do think this is for the signal for the synthesizer tail, so I don't need those anymore either. There's several edge cases that I needed to solve with this, like what happens if a train gets stuck in there, for example. How do I turn all the signals green? And several other things that I needed to solve, and usually I could solve multiple with one setup, and I think that's what it was part of. So I don't need this anymore. I don't need this anymore. I do need a way to decide. Okay, actually, what I should have done first is to get a second. Alright, so this one's basically my original show-off. I compute the numbers of trains. Okay, so this is where I compute how many trains I could serve with this load. So if if the numbers I could serve is, I might have to change this one. Train ID is T. It's actually in use anywhere. I don't think this is in use at all anymore. Read stop train. So let's change that to T. If it's greater, okay. So what did I do here? Up here I compute the number of trains that this station could serve. Right now that's wrong. We'll check that out later. Why it's wrong? Basically right now I could serve 0 trains, but this is saying I could serve 14 trains. So something is obviously off. We'll check that out later. So it's probably got to do with something I deleted somewhere here that's just now throwing, like not connected anymore or whatever. Something is off, but we'll check that later. It's just a bug to fix. And I set up this decider combinator so that when the number of trains I could serve is greater or equal to my threshold, send a signal to turn the station on. And this is the setting for the threshold. Is there? No, okay. I do wish you could just type these. Okay. This should still allow me to turn the entire system off. And indeed I can. So despite me being currently able to serve trains, I forced the station to be turned off. And I made a mistake when I deleted the white thing up here, because I still want, wait, oh, first I can just do this, and this one is if the latch, how do I, yeah, I think I can actually just leave it like this. Yeah. If the latch is turned off, as such, the station will be forced on so long as I haven't just manually turned the entire system itself off, which should still work, and it does. So turn it back on. Alright, so this part is done. For now at least. What do we have here? Let me actually... This time I won't make the mistake of not naming the system, the component, and we'll call it the latch. The 5, that's gotta be a filter. What is this for? If you're wondering how I'm moving stuff around, that's the dolly mod doing it. The picker dolly mod, and for some reason I can't use control upper arrow up. This might have 2 reasons. One could of course be the controls, another might be a script that I'm running that lets me set the focus of windows with control up. So could be that as well. I'm at this point inclined to simply do this. Yep. There you go. Much better. Okay. Right, I wanted to check what the system does. Turn off tags real quick. This is not connected to any global network. In fact, this should just be a filter. It's actually a latch. I think this is just a, yeah, okay. So this basically is just a memory of what item has been in the station. Turn you back to normal. Ah, keep forgetting that I don't. Okay. So it has the filter of the hazard concrete in it now. So if I put any anything else in there. Yeah, it does update. Okay, so this was there purely to remember what item this train serves, and I think I prepared that so that I could feed that information to the global network or use it elsewhere. So this is just a cache, basically. Um, these can be turned off, of course. They're not designed to report anything in particular. They're just legends. Let's move this out of the way. This entire thing over here is just first the memory for stack sizes, which I feed from this stack size provider over here, right? So there's a circuit when any memory anywhere at all requests information from the global memory. The system basically sends out whatever I have in here, and these are all the items in the game sorted by stack size. So here's stack size 1, right? So there's all the items with stack size 1, stack size 5, 10, 20, 50, and so on. If you're wondering how I do this, I have a video. If you look at my channel, or if you just look at the Reddit post in the description and follow to my profile, I have a script that basically checks all the items that you have available in the game. So this works on modded games as well, and sorts them according to stack size. So it'll simply give you like a line of constant combinators, and it will sort into these combinators by stack size, one after the other, every item that is available to you in the game. So that's the memory there. It's sorted by stack size. The circuit simply sends that information out when something requests it, and this memory has it saved. As long as the memory is, let's actually simulate that for a moment. There we go. Let's empty the memory. So the memory is empty, which alarms this combinator over here, or not this one in particular, but I think here, this one. If this combinator sees that the memory is empty, it sends out a signal I, which sets the counter over here running. In this counter, every 60 ticks, which is basically every 1 second, it'll cause the system to send out a request over the global network. You can see the output popping up once per second. This output goes out on the global network to this system over here. If I cut the wires real quick, you can see you're getting the eye every 1 second. You just can't see it right now because it's flickering really fast. But You can basically see every 1 second the entire system pops off. I hope that the 60th of a frame goes through on the recording. But this circuit basically takes care of delivering the information that's up here on the red wire, which I have not connected at the moment. That's why it's still going. It puts that information through the red wire and will eventually feed it into this memory up here. If I connect the red wires, there you can see now all the information of what item has what stack size is encoded in here. Although, oh yeah, it's in reverse. So there's some idiosyncrasies in the system. That's just part of the math. You don't have to worry about the strange numbers. It all works out in the end. For example, if we have, let's say, no, this doesn't work. It's not a special item. We have robots in here. We can see over here. This one should be it. Did I break the system somewhere? Or was that the reversal? I need to go through this tick by tick real quick. Let's delete the red wire. Let's delete the memory. Okay, stop time. Reconnect over here. Going through tick by tick now. RV40, couple more ticks. Okay, there's the request for information. There's the information out. It's available locally now through the collision check. And it checks for the correct message as well. Yeah, the numbers should actually be correct if I look at this. The numbers should be in a magic square, so the numbers should actually be correct. Weird as they are, they should be correct because I'm working with a magic square over here. The math savvy amongst you should definitely recognize these numbers. information is provided. It's gone through the math. Right, the stack size. Yeah, okay. It's all correct. I was worried for nothing. The I over here tells me how many stacks I have of robots over here, which is obviously exactly 1. I'd forgotten for a second how the system actually worked. So now I have 2 stacks of robots in here. Therefore, the I signal over here, the info signal tells me I have 2 stacks, right? And it does round up, so if you're wondering what happens if I had half a stack, it runs up to 3, obviously because the stack is taken up, and it'll still say 3 if I add another half stack to it, right? So basically, even if you no, that's not what I wanted. There you go. So even if you add only a single item beyond 1 stack, it'll round up, and this is intentional because if I wanted to fill the rest of the system up with, I don't know, something else, that would obviously count as a full stack already. In this system, it's not particularly important, but it's really important in the other systems like the depot over here, where a chain is actually designed to be loaded with many different items to deliver to you as the player while you're building outposts. Okay, so this works properly. This is the stacks calculator, but I'll just stick with stacks. Okay. So this is the stacks, and then over here we have the part that calculates how many trains we can serve at the number of stacks that we have. And it does this by checking our settings. So over here we say, okay, of our boxes that trains are loaded from or unload into, this I believe is the number of chests we have, and this is the number of slots per chest. I think might be the other way around. No, that's correct. So K is the number of boxes we have in total, which is obviously 48. If we check that, as you can see, 48 iron steel chests. And over here is the same with cargo wagons. So this station is currently designed to serve trains with 4 cargo wagons. So that's what the W says. And the C says how many slots per cargo wagon. And this brick over here uses that information first to calculate the 3 from here. It basically uses the information of how many slots do we have, or how much space, how many stacks can we load into a cargo wagon, and how many do we have in our inventory in the station. And it uses that information to supply how many trains could be served from the current fill level of the station. And I have a feeling that this is the reason why this is fucked up. So this is a loading station, right? So the loading station asks, of course, how many items are there and how many trains could I load with how many items we have here. So we have only one stack of robots, so of course it's wrong to say that we could serve 14 or more trains with that one item. And I have a feeling it's because this dude over here is actually the wrong dude for the job. Do we have down here? We need a loading station. This is an unloading station. And this is the loading station. And almost can't find my own way in this. Yeah, so this one is the stack signal. It's fed over here. It's just different signals for the same stuff. And basically what I did up here, I simply need to have the number of stacks I have turn directly into gray. So plus 0. Right. And there we can see we can serve 0 trains currently. So if I fill this up, oops. And here you can see the balancing in action. These just have items, while these are still empty over here. So obviously these cannot continue because I'm looking to load evenly across all chests as well as all wagons. So if I just put this in here, now you can see they're actually working in tandem. And you can see here the number of trains I could serve goes up. You can also see that happen if you look at this. 10, 11, 12. There we go. And if I dang it. What? Okay, you can see what happened. If we are empty, we can serve no more trains. On. You can see here the station is turned off because we cannot actually serve any trains in this one. As soon as there's enough to serve one train, let's actually fix that real quick. No. Bloody hell. Watch the light, watch the red lamp over here as it turns off once we can serve at least one train. That should be the, what did I put the threshold to? 1, yeah. As soon as we can serve at least one train, the station should turn itself on. One wagon. Two wagons. 3. And there's the train. Yep, we can serve one train now. The station has turned itself on, so my system indeed works as it should. And let's stop these from filling themselves. Okay. This was set to 5. That's why it happened so slow. Let's actually return this 12 for maximum stack size. Next time it'll go a bit faster. But what the hell? The slow speed of the loading because of limited items available. It's like less than half the speed that it would usually take. Worked in our favor here. For displaying purposes, you saw it slowly creep up, and as soon as we had a full chain available, the station turned itself on as it should have. I will need to add a system that actually tells the station to turn itself on. That adjusts the train limit. I'm sorry, kind of getting tired here. I think it's time to call it. That sets the train limit that the station is allowed to serve right over here. So that's basically probably going to be up here. This is as it needs to be. There's nothing I can change here. And I forget what this was for. First, let's put in what this is. So this is trains to be served. There you go. Trains to serve. I cannot remember what this was for. I think it had something to do with communicating towards the global network. How many stations can serve, are available to serve, no, actually are turned. So over here, I'm saving the item that I last saw in the station, right, in the station's inventory. And when the station is turned off, it sends the signal for the item of that station to the global network. So on the global network, I can see 2 iron plates. That tells me that 2 stations that serve iron plate are currently turned off. This is something that I need to rework, because in this fashion it isn't useful anymore. Instead, I want the number of trains that I can serve. And I might have to do some smart trickery to set it to be able to see how many trains I can serve to loading stations versus unloading stations, because that might be an important difference. But that's for another episode. Thank you very much for joining me. Look forward to the next one.